we start talking about power series and Taylor series for different functions. We said that if function f has power series expansion, if it has a Taylor series expansion, like f of x equals to e to the x, and if the remainder, the limit of the remainder goes to 0, you can definitely write that function as the sum of its Taylor series. For example, for e to the x, we saw that it's equal to 1 divided by 0 factorial plus 1 over 1 factorial times x plus x squared divided by 2 factorial plus x cubed over 3 factorial plus the rest of the terms. So this is just the expanded form. Expanded form. We saw that, hey, we can write this in compact form as the sum x to the n divided by n factorial and starts from 0, goes to infinity. Compact form. Well, now I expect you to ask, what if I plug in different values for my x? Question. What if we plug in different values for x? What do I mean by that? What if x is equal to 1? If x is equal to 1, we get f of 1 equals to e to the first power, which can be written as, okay, 1 over 0 factorial plus 1 over 1 factorial times x. In this case, your x is equal to 1 plus x squared over 2 factorial, 1 squared over 2 factorial, 1 over 2 factorial plus 1 over 3 factorial plus the rest of them, or it is equal to the sum 1 over n factorial, and starts from 0, goes to infinity. Okay, e is equal to the sum 1 over n factorial and starts from 0 to infinity, and it's equal to Napier number e. So if you see a question, in that question you have the series 1 over n factorial and starts from 0, goes to infinity, you quickly write the value of this series is equal to e. Nice and easy. What if x is equal to 2? X is equal to 2. It means that wherever I see x, I plug in 2. I have f of 2 equals to e squared is equal to 1 over 0 factorial, 2 over 1 factorial. Because here you have x, you get 2 over 1 factorial, plus here you have 2 squared over 2 factorial, plus 2 to the third divided by 3 factorial, plus the rest of the terms, or this is equal to the sum x, which is equal to 2, 2 to the n over n factorial, and start from 0, goes to infinity. What's the meaning of that? It means that if you see a series of the form 2 to the n divided by n factorial, you quickly say, hey, this series has a sum. That sum is equal to e squared. You continue this process. We have more x values that you can plug in here, and you can write it in expanded form, and the compact form gives you the series notation. Okay, perfect. So I'm going to analyze two series for you. I'm going to write them side by side so you see how we analyze these two series. Example. Analyze f of x e to the x Taylor series when a is equal to 0. So you can say that since a is equal to 0, this Taylor series is called Maclaurin series. It doesn't matter. Maclaurin series. And then you write this one here. Next example. Analyze f of x equals to e to the x Taylor series when a is equal to 2. So note that I'm changing the center. The center was 0. Now the center is equal to 2. Okay, let's follow some steps. Step 1. So in this step, we're trying to write down the Taylor series. Remember that yesterday we talked about the theorem plus the Taylor's inequality that showed us that we can write this function as the sum of its Taylor series. So since we already proved this, we're not going to reprove this. If you want to take a look at your note, get back to yesterday's note and review what we did yesterday. So in step 1, first we check the theorem, the Taylor's inequality, to show that the limit of the remainder goes to 0. And now, we also yesterday learned that e to the x can be written as 1 over 0 factorial plus 1 over 1 factorial, and it's 1 times x squared divided by 2 factorial, plus the rest of the terms, or in compact form, you have the sum x to the n factorial, and starts from 0, goes to infinity. This is your step 1. In step 2, you're interested in finding the radius of convergence. How do we find the radius of convergence? We use the ratio test to find the radius of convergence. Find R, or the radius of convergence, by using the ratio test. I saw one question about finding the radius of convergence in Piazza. I answered to that. But whenever you want to find the radius of convergence, you have to use the ratio test. Ratio test tells us the limit of absolute value of an plus 1 divided by an must be less than 1. So you have x to n plus 1 divided by n plus 1 factorial divided by x to the n over n factorial. This must be less than 1 while n goes to infinity. This is our ratio test. This is the general form. Now we need to simplify the limit on the left side. It says the limit of absolute value of x to the n times x times n factorial divided by x to the n times n plus 1 factorial. N goes to infinity. I'm trying to just simplify my left-hand side. You can cancel out x to the n, x to the n. Here you have n factorial and n plus 1 factorial. Remember that n plus 1 factorial is equal to n plus 1 times n factorial. That's how you can simplify this limit. You get the limit of absolute value x times n factorial divided by n plus 1 times n factorial. N goes to infinity, and this guy must be less than 1. Again, you have some common factors, n factorial and n factorial. This limit is equal to the limit of absolute value of x divided by n plus 1, while n goes to infinity and it must be less than 1. But if I take the limit on the left-hand side, the limit is equal to 0. 0 times absolute value of x is equal to 0. So the limit is 0. This is always 0. This is always true. Since this is always true, it means that if you plug in any value for x, this series is equal to e to the x. It is true for any x value. Okay, so the radius of convergence. What is the radius of convergence? You have the limit of, just writing this right here, you have the limit of 0 times absolute value of x, you don't need the limit anymore, less than 1. So absolute value of x is less than 1 over 0, which is infinity. So your absolute value of x, which is less than infinity, gives you this inequality. X is in between negative infinity to positive infinity. So r is equal to infinity, and step 3, which is the radius of convergence, and then the interval of convergence. This is negative infinity to positive infinity. Now let's move on to the next one, when a is equal to 2. Okay, now I'm changing the center. My center is not 0 anymore. My center is actually just 2. So again, if you look at the theorem and Taylor's inequality, you can show that the limit of the remainder goes to 0. So e to the x is equal to the Taylor's expansion. But in this case, your a is not 0. A is 2. So we need to find those coefficients. E to the x is equal to c sub 0, c sub 1, x minus a, c sub 2, x minus a squared, plus the rest of them. And remember that c sub n is defined as the nth derivative, but here you don't have any 0, you have 2. So you get the nth derivative at 2 divided by n factorial. Okay, c sub 0 is equal to the 0th derivative of the function, which is e to the x, evaluated at 2 divided by 0 factorial. You get e squared over 0 factorial. C sub 1 is the first derivative of e to the x, which is e to the x, evaluated at 2 over 1 factorial, which is equal to e squared over 1 factorial. C sub 2 is the second derivative. Second derivative is the same as e to the x, evaluated at 2 divided by 2 factorial, e squared divided by 2 factorial. You can continue this process. If you continue this process and then plug them in, e to the x, Taylor's expansion at center 2 is equal to c sub 0, e squared over 0 factorial plus e squared over 1 factorial, x minus 2 plus e squared divided by 2 factorial times x minus 2 squared plus the rest of the times. Okay, we can write e to the x in actually compact form as e squared times the sum x minus 2 to the power n over n factorial, n starts from 0, goes to infinity. So this starts step 1. and these are our C sub n values, the calculation, and here you have your Taylor's expansion at A equals to 2. The center is 2. Now let us move on to step 2 to find R. Step 2, to find R, we need to use the ratio test. Taking the limit, you have the limit of absolute value of e squared times x minus 2 raised to n plus 1 over n plus 1 factorial divided by e squared x minus 2 to power n over n factorial. While n goes to infinity, this guy must be less than 1. We know that. It must be true. Okay, let us simplify this. You get e squared cancel out. And here you have the limit of absolute value. You get x minus 2. You can cancel out n and n. And here, if I flip this, I get divided by n plus 1. While n goes to infinity, this guy must be less than 1. But it is less than 1. Of course, when you take the limit goes to infinity, this is equal to 0. This is always true. 0 is less than 1. Always true. For any value of x. For any value of x. There you go. Again, you have 0 times absolute value of x minus 2 less than 1. So absolute value of x minus 2 is less than infinity. Your infinity is your R. And step 3, to find the interval of convergence, you have x minus 2 bounded between negative infinity to infinity. So x is between negative infinity to infinity. This is your interval of convergence. Of convergence. Next example is actually analyzing Taylor series of sine function at a equal to 0.